Hi everyone! Today let's talk about session 3.5, some elementary theorems. Theorem, additional rule for mutually exclusive events. If A and B are mutually exclusive events, what does mutually exclusive events means? It means A and B, they are disjoint, so their intersection is empty. And the probability that event A or B will occur, so that's the probability A or B. We can also say probability of A union B equals probability of A plus probability of B. And then we also have the general addition rule for two events. So the probability that event A or B will occur equals probability of A plus probability of B minus probability of A and B. So why is that? Okay, let me draw a picture here, then you will understand. So we have A and B. Okay, so we want to compute the probability of A or B. So this is the probability of A or B, right? And so that is the probability of A. What is A? So A is this region and this region, right? Plus the probability of B. So probability of B. Probability of B is this region and this region. Now, do you realize the middle region we actually counted twice? Okay, so this region we counted twice. That's why we need to subtract it back. So that's why we want to subtract probability of A and B. Okay, everyone? So that we count each region. So this is the union. We want to count each region only once. We don't want to double count it. Okay, so that's why we have that. Alright, and we also have the general addition rule for three events. The probability that events A or B or C will occur is given by the following. Why is that? Okay, let me draw a picture here. So we have A, B, and C. Let me make the A bigger because it's not big enough. Okay, so this is A. Alright, now let me use the color. Probability of A or B or C is probability of A. Probability of A is this is region, this region, this region, this region, right? Probability of B is this region, this region, this region, this region, right? Probability of C is C, this region, this region, this region, this region. So far, so good, everyone? Okay, next. Minus probability of A and B. Because, think about it, because you see these regions, we double counted, so we want to subtract. So we subtract A and B. A and B is this piece, right? So we subtract this region and we subtract that region. A and C is this region, so we subtract this region and subtract this region. B and C is right here, so we subtract this region and this region. Now, can you see we have this region is good because we only counted once. This region is good because these guys cancel, so then we only counted, oops, we only counted once, right? Sorry. Okay, I want to, okay, alright, so this one is good. And then this also good, this is also good, this is also good, and this is also good. But the problem is the middle region. Do you see 3 plus and 3 minus? So actually we subtract all of the middle region. So we need to add it back. So that's why we need to add A and B and C. So A and B and C is this middle guy. Okay? Alright, and I hope through this picture you can understand this general addition rule. And this rule is also called inclusion-exclusion principle. because here we include ABC, and then we exclude the intersection of 2 of them, and then we include the intersection of 3 of them. So actually these rules work very similar for more events. So if we have more than 3 events, we include all the PA, PB, PC, PD, etc. And then we subtract the intersection of the probability of intersection of each pair. And then we add the probability of intersection of 3 of them. Okay, and then we minus the probability of 4 of them. So you just keep going. So that's why it also called inclusion exclusion principle. Okay. All right. And notice that the addition rule for mutually exclusive events is like a corollary of the general rule, because if the probability of if A and B are disjoint, then the probability of A and B is 0. That's why this guy is gone. Okay? Alright, let's continue. Example 1. In the probability experiment of a randomly selecting a card from a standard deck, what is the probability of getting a king or a diamond? So king or diamond, we want to use the general addition rule. Okay, so we want to ask, is there a card which is king and diamond? Yes, the diamond king. Right, so is there a card which is king and diamond? Yes. So that's why they are not disjoints. So we use the general addition rule, which is probability of king plus probability of diamond minus the probability of king and diamond. How many cards there are kings? So 4 kings, right? And in 52 cards. How many diamonds? 13. And there's 1 king and diamond king. Okay, let's see. 4 plus 13, 17, minus 1, 16. Okay, and the common factor is 4. 16 divided by 4 is 4. 52 divided by 4 is 13. So this is the probability of king or diamond. Okay, next. The complement of event A is the set of all outcomes in a sample space that are not included in an event A. The complement of event A is denoted by A complement. So you can use the bar on it, or you can use AC to denote complements. But we usually use the A bar. Okay. Complement rule for a probability. The sum of the probabilities of an event A and its complement is equal to 1. So because we know the general addition rule, so P of A or A complement equals P of A plus P of A complement minus P of A intersect A complement. But because they're disjoint, so the probability of A and A complement is 0. And notice that P of A or A complement, this is the entire sample space, so that's why it equals 1. So that's why P of A complement is 1 minus P of A. And remember, if in the Venn diagram, if this is A, then this is, maybe I should put the A inside here. So this is A, and then A complement is outside of A. Okay, so this is A complement. Sometimes it could be easier to compute the complement rather than A. Okay, so let's look at example 2. Roll a fair die 4 times. Find the probability that some numbers appear more than 2 times. If you want to compute the probability of some number appear greater or equal to 2 times, okay, first of all, some number, this number it could be 1, 2, 3, 4, 5, 6, a lot of cases. And appear greater or equal to 2 times, while it could be 2 times, 3 times, 4 times. Because we roll the fair dice 4 times, it could be at most 4 times. So that's why if you want to compute this probability of this event directly, wow, it has a lot of cases, right? So now let's consider its complement. So let A be the event of some number appears greater or equal to 2 times. What is the complement? Well, some number complement is all number appears negation of greater or equal to 2 is then less than 2. Less than 2 means less than equal to 1 time. So all numbers appear less than equal to 1 time, at most 1 time. So this guy is much easier to compute. Okay, so what is probability of A complement? Okay, something wrong with the word. Let me save it first. Okay, now I can write on it. Probability of A complement. So we roll a die 4 times. And then the first time, okay, because all numbers appear less than equal to 1 time. The first time it could be all the numbers. So 6 possibilities there. The second one, because all numbers appear at most 1 time, so that's why the first number cannot appear now. So there are only 5 possibilities. And then for the third number, because we already picked 2 numbers and they don't appear, they don't repeat. So that's why there are 4 possibilities. And then here we have 3 possibilities. So 6 times 5 times 4 times 3. And let's see. 4 times 5, 20, 20 times 3, 60, 60 times 6. 360. Oh, okay. Because, be careful everyone, I almost make this mistake. We are talking about probability. We're not talking about the number of ways. So now, all this is going to change. So the probability, the total is 6. We have 6 numbers. So that's why you want to all over 6. Okay, everyone? We want to divide it by 6 because we're talking about the probability. Probability must be a number between 0 and 1. Okay, now let's see. This cancel. And 3 and 1 of the 2, we can cancel 1 of the 6. And then these cancel, we can get 3. So we get 5 over 3 times 6, 18. So this is the probability of the complements. Okay? And now, what is P of A? P of A, equals 1 minus P of A complement 1 minus 5 over 18, so 13 over 18. Okay, so this is much easier than computing the probability directly because you need to think about, okay, some number, which number? There could be 1, 2, 3, 4, 5, 6 numbers, so you have different cases. And after you fix a number, then you want to think about, okay, that number appear how many times? It could be 2, 3, 4. So a lot of sub cases. So that's a lot of work. Okay, but here when we compute the complement, is much easier. Okay, good. Let's continue. Example 3. 15% population is blonde. 25% has blue eyes. 2% have both. What is the probability of randomly choosing a person who is neither? Okay. So, let's see. Okay. Neither means not blonde and not blue eyes, right? So we can first compute, Okay, let's see. Let's say A. Let's define the event A of choosing the blonde. And B be the event of choosing blue eyes. Okay, and then A union B means is either but is blonde or blue eyes. Okay. Alright, so what's P of A union B? That's P of A plus P of B minus P, A, and B. Okay, P of A, 15% is bond, so 0.15. P of B, 25% has blue eyes, so 0.25. Minus both 2%, so 0.02. Be careful, 2% is not 0.2, it's 0.02. So be careful about that. So this is 0.4 minus 0.02, then we get 0.38. So this is blonde or blue eyes. How about neither? Neither is like not A and not B. And what not A and not B is actually not A or B. Okay? Then, so we know this is 1 minus 0.38, which is 0.62. Okay? And why this is true? This is actually the De Morgan's law. Okay? A or B complement is A complement and B complement. So the complement is, the analogy is like the negative. Okay, remember the negative flipped the inequality, right? So this is similar to it. When you distribute the negative or complement, it flipped the union. Now it becomes intersection. Similarly, A intersect B complement. When you distribute the complement, it also flips the intersection, now become union. So this is the De Morgan's law. Okay. And if you want to draw a Venn diagram to help us understand this, okay, A or B complement. A or B complement is this. Okay, and A complement. So A complement. This is A. A complement is this. A intersect B complement. So B complement is this. Now you can see the intersection, which is the common region, is exactly this. Okay, so you can also show it by the Venn diagram. Okay, good. Let's look at example 4. The following table represents the employment status and gender of the civilian labor force age 16 to 24 in millions at a particular point in time. So, and unemployed, employed to total, and we also have male, female, and total. Okay. What is the probability that a randomly selected 16 to 24-year-old individual from the civilian force is employed? Okay, so how do we calculate this? This is finding the probability of employment. And so employed is right here, okay? And because it does not mention male or female, that's why we consider the total. Okay, the probability is the number of employed over the total. The total is 24.5. Okay, what is this number? So calculator, we have 21.5 divided by 24.5. The answer is 0.8776. If we keep 4 decimal places, we need to round up, right? 8776. 0.8776. So far, so good, everyone. Okay, part B. What is the probability that a randomly selected 16 to 24-year-old individual from the civilian force is male? So male, where's male? Right here. And because it does not mention this employed or unemployed, we should pick this number 12.8. And divided by the total. The total is 24.5. So 12.8 over 24.5. So 12.8 over 24.5. So the answer is 0.5224. So I hope, like, for all your answers, if the problem didn't specify, please keep 4 decimal places. Okay, or like 4 significant digits. For example, if the answer has a lot of zeros, please keep 4 significant digits. Don't just keep 4 decimal places, because then the answer is not so good. Okay, keep 4 significant digits in this case. Okay. Part C. What is the probability that a randomly selected 16 to 24-year-old individual from the civilian force is employed or male? Okay. So probability of employed or male. This is like union. So we need to use the general addition rule. So this is the employed plus probability of male minus probability of employed and male. Okay, employed is 21.5 over 24.5. Male, 12.8 over 24.5 minus employed and male. Employed and male is what? Right here, 11.2. So what is that? Okay, you see we have the common denominator, and let's see, the numerator 21.5 plus 12.8 minus 11.2, and that's 23.1. Oops, sorry. So 23.1, and we get that number divided by 24.5. So the answer is 0.9429, round up, right? Okay. So that is the answer for this part. Okay. And this is example 4. So that's it for session 3.5. If you have questions, feel free to ask me. Have a nice day. Bye.